Well, I've done research in both physics education and in experimental high energy physics, and I've enjoyed both of those. The physics education was my first introduction into research, and it was a really great place to start. I'm still really interested in educational philosophy and how students learn, and I think it's great that in the physics community they're aware of this need to make sure that we're teaching physics the best way we can, because it can be difficult and hard to understand, and so if you're not aware of how students make connections between the equation they see on the page and then what happens when you toss a ball up and then it falls, that it's just going to get lost somewhere in there. And so physics education really works to bridge that gap between theory and practice. And then my research now is in experimental high energy physics, which I also really, really like. I mean, it's just exciting. We collide particles that are moving at almost the speed of light, and then we see what happens. So that's just fundamentally pretty cool. So it's a fun place to be. It's also good because I have a good answer when people ask me what are the practical applications of your research. A lot of times when you do theoretical science research, it's hard to justify to the general public why they should fund it. But historically, all advances in physics and in fundamental science have turned into technologies that have increased the quality of human life. And so like particle accelerators were just big machines that were built for physicists initially, but they've turned into machines that doctors use, such as NMR and MRIs, and those things save lives. And so physics is good because it's fundamental, but it's also good because it's applied.